Hey guys, the objective of today's video is to give you an introduction to clay mineralogy. I'll be comparing the behavior of different types of soils, and I'll also quickly touch on clay minerals. Now, why is clay mineralogy important? Well, it allows engineers to understand why clay exhibits certain behaviors. For example, how much volume change to expect when the clay comes into contact with water, or how well the clay soil will be able to withstand a load. Now, in civil engineering, the term clay actually refers to a clay soil. And a clay soil is a soil that contains enough clay minerals to affect its engineering behavior. And a clay soil behaves cohesively as well as plastically. Let's now have a look at the behaviors of the different types of soils that we know about. In a granular soil, such as gravel and sandy soils, the grain size distribution and grain shape affect the engineering behavior of these soils, whereas water is generally not very important in its behavior. Now, with a clay soil, we find that the converse holds true. So the grain size distribution has relatively small influence on its engineering behavior, whereas water has an effect on the behavior of the clay soil. Silt, on the other hand, behaves somewhere between that of granular and clay soils. The engineering behavior of silt is affected by water, but like sand, its strength is independent of water. And the reason that water has an effect on the behavior of clay soils is because the clay minerals are very active electrochemically. The presence of even a small amount of clay can affect the engineering properties of the soil. And as the amount of clay increases, the behavior of the soil is increasingly governed by the clay. Now, when the clay content reaches about 50%, we find that the sand and silt grains are essentially floating within the clay matrix. Let's talk about clay minerals now. Clay minerals are tiny crystalline substances which evolve from the chemical weathering of certain rock-forming materials. For example, feldspar, which comes from magma. The individual crystals look like tiny plates or flakes and can only be seen using an electron microscope. From X-ray diffraction studies, scientists have found that these flakes are made up of many crystal sheets which have a repeating atomic structure. And it has been found that there are two fundamental crystal sheets which form the main building blocks for clay minerals: a silica tetrahedral sheet and secondly, an alumina octahedral sheet. As the names may suggest, a tetrahedral sheet is made up of units which have 4 faces, and an octahedral sheet is made up of units which have 8 faces. We'll talk more about this in the next video. Hope this helps, guys.